Hey guys, we are going to be starting our next unit for trig. It's going to be our chapter 6, our solving trig equations unit. We're going to start off today with solving for some variables or some values of theta that we're familiar with. And then we are going to move on and we are going to start looking at values outside of the significant ones that we've already learned on our unit circle. Okay, so for these first two problems, we're solving each equation for theta when theta is greater than or equal to 0 or less than 2 pi. When you're solving problems like this, you want to think of your sine of theta as your x. This is what we're trying to isolate. That's what we want to get by itself. So if I have -1 equals -1 minus sine of theta, and I want to get sine theta by itself, I can start off by just adding 1 to both sides of my equation. Right? Those cancel each other out, give us 0. And then over here, -1 plus 1 also gives us 0. So I have 0 equals negative sine of theta. Right? I can always get rid of a negative, okay, by dividing out a -1 on both sides. Well, 0 divided by -1 is still 0, so I have 0 equals sine of theta. All right, now this is like one of the problems that we worked on in our last unit. If I want to figure out sine of theta equals 0 and I'm trying to solve for theta, I'm going to ask myself, okay, where on my unit circle, when I look at my terminal points, is y equal to 0? I say y because our definition for sine is y. So if we think about it on our unit circle, put in a little circle here, right, my y value is 0 at two locations. Right, my y value is 0 at 0 when theta equals 0. Right, but my y value is also 0 at pi. So I'm going to have theta equals 0 and theta equals pi. Notice, guys, I did use 0 instead of 2 pi, and that's because of this restriction on theta up here. All right, I have theta is less than 2 pi, so 2 pi is not included. So my answer for theta, for question 1, is going to be 0 and pi. Right, now if we look at the next equation, or the next problem, this time we want to solve for tangent of theta. Okay, so we're going to treat this just like we have before. Right, I'm going to go ahead and rewrite the equation, question 2. So I have 6 minus the square root of 3. All of that's over 3 equals 2 minus tangent of theta. All right, so we want to go ahead and get tangent theta by itself. So I can do that by subtracting 2 from both sides. I'm going to end up with 6 minus the square root of 3 over 3 minus 2 equals negative tangent of theta. Right, I do want to simplify this 6 minus the square root of 3 over 3. Right, we can split this fraction up. We can think of it as 6 over 3 minus the square root of 3 over 3. And then we still have that minus 2 equals negative tangent of theta. Right, and you'll notice that by splitting up that fraction, it makes it a little bit easier for us to see how we can simplify it. Right, we can take 6 and divide it by 3, and we end up with 2 minus the square root of 3 over 3 minus 2 equals negative tangent of theta. All right, well, we can take 2 and subtract 2. They're going to cancel out, or they're going to give me 0. And so I am going to end up with a negative square root of 3 over 3 equals negative tangent theta. Right, I can go ahead and get rid of my negative tangent, divide both sides by a negative, and that's going to make both of them positive. Now that we've got tangent by itself, this is looking more like a problem that we saw in our last unit. right? So I need to ask myself, what's the definition of tangent? Right? Tangent is y over x. So which terminal point on my unit circle, when I take y and divide it by x, gives me a square root of 3 over 3? Right? And if we remember properly, that is going to be at pi over 6. So at pi over 6, let me get my pen going again. I have tangent theta equals square root of 3 over 3. Right? But remember, tangent is positive not only in quadrant 1, but also in quadrant 3. So not only is my answer going to be pi over 6, so theta equals pi over 6, but in quadrant 3, I'm also going to have 7 pi over 6 as part of my solution. Right? And so my answer for this one is going to be pi over 6 and 7 pi over 6. So once we isolate our trig value, whether it's tangent theta, sine theta, cosine theta, any of those, right, then we just have to use our definition in order to identify the correct thetas, our definition for our trig functions, sine, cosine, tangent, all of those. So this next one's going to be a little bit more tricky because you'll notice we have a cosine squared theta as well as a cosine theta. Okay, so we have a squared and just a regular cosine. And just like if I'd given you a problem such as x squared plus 3x plus 2, and I asked you to solve for x, we know that we can't combine my x squared and the x. So in order to isolate x, what would we do? Well, we would factor this. We would say, all right, well, x plus 2 times x plus 1 is the factored form of this, set it equal to 0, and then we could solve for each factor individually, and we could identify our values of x. That's what we're going to do for this problem. Right? So if we have cosine squared theta equals negative cosine theta plus 1 minus cosine squared theta, we can't combine the cosine squared with the cosine. So I'm going to start off by moving everything to one side and setting the other side equal to 0. So I'm going to go ahead and move everything to the left, okay, the left-hand side of my equation. So I'm going to add cosine squared theta, I'm going to subtract 1, and I'm going to add this cosine theta. Okay, when I do that, I end up with cosine squared theta plus another cosine squared theta plus cosine theta minus 1, and all of this is going to equal 0. I can combine my two cosine squareds, so I end up with 2 cosine squared theta plus cosine theta minus 1 equals 0. Right, so because we know we can't combine my cosine squared with the cosine, I'm going to go ahead and factor this. Think of that cosine squared theta and cosine theta, just think of it as x's, and we're going to follow the same factoring techniques we would always use. Since there's a 2 in front of my cosine squared, I'm going to do my AC method. I'm going to multiply a times c. Right, 2 times negative 1 is negative 2. Right? I want my factors of negative 2 that are going to add to b. In this case, my b is the coefficient in front of cosine, and since there's nothing there, we know it's just a 1. So my factors of negative 2 that add to 1, it's going to be positive 2 times negative 1. Right, so I'm going to rewrite this. I have 2 cosine squared theta plus 2 cosine theta minus 1 cosine theta. I'm rewriting that middle term using my factors, and I still have this minus 1 out front. Actually, at the end, right? Not out front, at the end. Okay, then I'm going to factor by grouping. So I'm going to group my first two terms. Right, what can I factor out of a 2 cosine squared theta and a 2 cosine theta? Well, I can factor out a 2 cosine from both of those. So when I factor out that 2 cosine theta, I'm going to be left with cosine theta plus 1. All right, now I look at my other two and I'm going to say, all right, what can I factor out of a negative cosine theta and a negative 1? Well, the only thing I can factor out that would be a negative 1. So I'm going to go negative 1, and I end up with cosine theta plus 1. All right, notice I have a cosine theta plus 1, cosine theta plus 1 in both of these, right? So I can rewrite this. I can take the outside numbers and write this in factored form. I have 2 cosine theta minus 1 times cosine theta plus 1. And that equals 0. Now that I have it in factored form, I can set both of these factors equal to 0 and solve for theta. So I'm going to start off with my 2 cosine theta minus 1 and set it equal to 0. Right? And then I also have my cosine theta plus 1 and set that equal to 0. Right, I'm going to go ahead and move over a little bit so I have more room. Right, so I'm going to kind of come up to the top here. 2 cosine theta minus 1 equals 0. If I want to solve for this, I'm going to go ahead and move that 1 over. So I have cosine theta equals 1, 2 cosine theta. Right, and then to get rid of that 2, I'm going to go ahead and divide it out from both sides. And I end up with cosine theta equals 1/2. All right, so now I can solve for this first value. All right, cosine theta equals 1/2. I'm going to think back to my terminal points on my unit circle. My definition for cosine, it's the x value of my terminal point. So when on my unit circle is the x value equal to 1/2? So I know that x equals 1/2 at pi over 3. Right, x is positive in quadrants 1 and in quadrants 4. So it's going to be pi over 3 and 5 pi over 3. All right, now I still have one more that I need to solve for, because remember I did have 2 factors here. All right, I also have to solve for this cosine theta plus 1. So I'm going to come over here and I'm going to say, all right, cosine theta plus 1 equals 0. I'm going to move my 1 over. So cosine theta equals negative 1. Right, and now I've got to ask myself, all right, when does cosine equal negative 1? Or in other words, when on my unit circle, okay, do I have a terminal point with an x value equaling negative 1? In this case, I know that x equals negative 1 at pi. Right, so for this problem, I actually end up with 3 different solutions. Right, I have theta equals pi over 3, pi, and 5 pi over 3. And those are my final answers.